In this video we'll be looking at a little bit more of a basic example, but this time that we have to find the derivative function and we're not plugging in a value at the end. So in this case there's actually just one less step in the problem. So what we're going to do is we're going to go ahead and say that f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. And to evaluate this, again, I'm just going to go through the steps of plugging in the values. I'm going to replace my x in this function with x plus h, giving me 3 parentheses x plus h minus the 4. That is the original function with x plus h replacing the x. I'm going to subtract from that 3x minus 4. Again, that's the original function, unchanged entirely. This is all divided by h. Now again, you'll notice here that I'm not doing this f of x plus h stuff at a separate stage. You can do it this way, or you can continue to do it the way that we've been doing it, where we identify f of x, then off to the side identify f of x plus h, simplify f of x plus h, and then plug it in. But in this case, I'm simply just going to get lazy and plug it all in all at once. So I'm going to distribute the 3. That's going to give me 3x plus 3h minus the 4. I'm going to drop those brackets, and I'm going to distribute this negative to both of those terms, giving me minus 3x plus 4, all divided by h. I'm going to go ahead and simplify term by term that I can. The positive 3x can cancel out the negative 3x. The negative 4 can cancel out the positive 4, leaving me the limit as h goes to 0 of 3h over h. The h is canceling out, leaving me the limit as h approaches 0 of 3, giving me back 3. Now this particular problem should make a lot of sense. Let's talk about what the derivative is one more time. The derivative is the slope at a very specific point. Well, if I'm looking at this function right here, this is a linear function, and the slope at every point on this line should be the value of 3, again, mx plus b. So that means that if I'm looking at the derivative at a given location, that 3 provides me with that slope. So again, this does reinforce the fact that the derivative at any given point x is equal to 3 on this linear function.